Welcome to Elemental Fun, a historical and cultural look of the elements of the periodic table. Hello and welcome. My name is Grace.
My name is Cindy.
And we are here to talk about one of the coolest elements out there and the most common element out there, carbon.
It's everywhere.
It is.
Literally.
And not figuratively.
Right.
Literally.
Literally
like
everywhere.
It's in everything.
It's in you.
It's in the air.
It's in this table.
It's in the table.
Yeah.
Cool.
Yeah.
So we're going to talk a little bit about, we can't talk about who discovered it because
Nobody did.
No. It's been around forever. And
caveman.
Yes, we're going to name the caveman who discovered it Dr. Gronkfoot. Ouch.
Dr. Gronkfoot Ouch?
Yes.
That's an impressive name.
You know, he
Well, he did get a doctorate.
He does.
It's for a caveman. That's
Yes.
pretty impressive.
I know. Anyway, so we can't talk about who discovered it, but we could talk about where it's found in nature, and we could talk about its early uses and throughout its wonderful impact in history up to modern day uses.
Yes. That sounds good.
Cindy, it was not discovered. However,
No. We've always known about it.
yes.
Nobody can say, aha, this is the day that carbon was discovered. I have discovered it and I'm awesome. Nobody could do that. So basically, it's been around since ancient times, but it's first recognized as an element in the late 1700s or the 18th century.
Did you have a name of someone who was able to figure that out?
No, I do not.
I really couldn't either.
No.
However, we can't tell you that carbon
Bob.
gets its name. Dr. Bob.
Dr. Bob.
We can say that carbon gets its name from the Latin word carbo, which means coal. So it does have a Latin root name, which may impact where or who discovered it was probably Latin.
Well, everything's basically Latin. Anything biology.
I'm trying to
chemistry-related.
sound smart, Cindy.
Oh, well, you are.
Oh, thank you. I don't get told that very often. I'm just kidding.
Latin's everywhere.
So anyway, so tell us a little bit about where it's found in nature, Cindy.
It's found everywhere.
Yes.
Yes. So one of the coolest things is that the carbon that we have in our bodies has come from carbon dioxide gas.
What?
In a roundabout way.
Tell us the roundabout way.
Because we obviously rebreathe out carbon dioxide.
Yes, we do.
Right. Well, that would not be good to breathe in. But on the other hand, plants breathe that in through photosynthesis.
Oh, I know about this. I remember biology.
So the sunlight and carbon dioxide goes into the plant, you give it some water, and out comes sugars. So the carbon that was in the carbon dioxide is now packed in the nice little sugars, like glucose.
I'm going to get myself some carbon after this.
Delicious. So the plants pack away that carbon into its nice little sugar, and then we go and rip those plants out of the ground and eat them. All that stored energy, just for us.
Ferociously
Just
demolish
rawr, right. So, and then we get that sugar, and then we break down that sugar through cellular respiration.
Okay.
Which is the opposite of photosynthesis.
Breathing
which is
out,
kinda cool.
basically.
Right, yeah.
Okay.
So we take in oxygen and breathe out carbon dioxide, whereas plants breathe in carbon dioxide and breathe out oxygen.
But we're going to talk a lot on this episode, not so much about how carbon can be in the air and carbon dioxide, carbon monoxide, because that involves chemical
Reactions. That's
Thank
it.
you. And we're going to focus more on its original form, its
Or
solid,
natural form.
natural form,
Yeah.
and its solid form as well, because it's natural that it's in the air.
This is true, yes.
But we're going to talk more about
The physical, what you can touch.
Yes, and the most stable at regular room temperature and regular pressure, the most stable one is graphite. Correct?
Yeah, it's also the softest. It's one of the softest materials.
What's amazing about carbon is it is at the same time, it is one of the hardest elements in the world.
That would be a diamond.
Yes. And one of the softest in graphite.
Graphite.
And so it can be in both
although
forms.
the diamond is not the strongest anymore. But we'll get to that later.
Okay, we're going to
Spoiler.
You just take
Take the thunder. Okay.
Take my thunder
Sorry.
right out from under me. Rug or something. I wish you could have seen her hand movement of her pulling the rug out.
I talk with my hands. Yeah.
Yes. Too bad you can't see this.
Damn it.
I know. Did not think this through.
No.
We should have vlogged this.
No. Next time.
No.
Or down the line.
Maybe
No.
not.
You may not want to see our faces.
Maybe not. Anyway. So where else can it be found in nature in its natural form?
Well, carbon, really what they found carbon, back our caveman, Dr. Gronk, ouchie foot or something?
Ouch, yes.
Foot ouch. Yeah,
MD.
something like that. Was basically like charcoal or coal. They have a lot of different terms for that. And I am looking for amorphous carbon.
Amorphous.
Amorphous. Do you know what amorphous means?
Well, I know that a means usually
Without.
Without.
Correct.
Or not,
See, you are smart.
Amorphous means to change. So
Yeah, without changing.
without change.
So it is if you burn carbon without enough oxygen to burn it completely. And so you get like basically the coal or they call it black soot or lamp black or gas black or channel black or carbon black. Because, we like to just name things a whole bunch of different ways. It's really confusing.
Such an English thing to do. Can't be like the Greek and just have like a certain amount of letters, could we?
No.
Well,
Just
we
got to
do
keep
have
going.
a certain amount of letters,
Well.
but I'm just not winning today.
So basically you have that kind of carbon, you have graphite, and you have diamond. Those are the naturally occurring, and I'll throw out a word here and you can ring your little bell, allotropes.
Ding. Ding, ding. I don't have a bell yet.
But what's really cool about carbon, this is probably the coolest thing about carbon,
Please tell me.
is that all of those, it's all just the element carbon. There's nothing else in there. It's just arranged differently.
That is so cool.
So the graphite, which is one of the softest materials, and the diamond and the buckyballs that we'll talk about later, are all the same, just carbon in, I just bumped the mic. Sorry. Oh, again, I'm talking with my hands. I'm sorry. So the carbon...
Showing me how it's formed. It's
right?
really fascinating. I wish you could be here for this.
So the carbons are all linked together, and how they're linked together tells you whether it's graphite or diamond or something else.
So cool.
So it's just the arrangement of one element. It's really, really cool because and the other cool thing about carbon besides that is it's called what we call a biological tinker toy. Did you ever have tinker toys when you were little?
I did.
Okay. I wasn't sure. You're younger than me, so oftentimes
I have older siblings.
all right. Oftentimes I say things in class and the kids are like, yeah,
Well,
blank.
I'm not an
Blank stare.
18-year-old.
I have older people in my class and they're still like, what?
That's true. No,
Yeah.
but tell us.
Okay.
Tinker
Anyway,
Toy.
Tinker Toy. So the Tinker Toy was a toy that you had that had, like a circular disc and you had a bunch of holes in it and then you could put the sticks in. So you could literally create almost any kind of structure you wanted.
It was super fun.
Right. So the reason why carbon is a Tinker Toy is because it has 4 places that other elements can bond to it, which is...
Because it's elemental number 6, right?
Yes.
And
So
it
it's
has
in that
4
same group.
electrons in the outer...
Electron shell. The
Yeah.
the valence electron shell. Look
oh
at
my
you.
goodness. I pulled that out of 2002. Yes.
Nice. Those outer electrons are what I call the personality of the element. So it causes it to react in a certain way based on what electrons are there and how they bond and how they react with other elements. Because they all want to be like the noble gases because they want to be full and complete.
Right.
Right.
I remember this.
Because everybody wants to be a noble.
I want to be complete. And there's our cultural
Reaction.
connection to
Right.
chemistry.
You always want to be complete, just like the nobles. Although I think after watching Game of Thrones, everybody realized you don't really want to be a noble.
I was thinking just of the gases and not as like royalty. That's
I always
gene
go to
pool
royalty.
is just
Not good.
It's not a family tree. It's a family wreath.
It's true.
Anyway,
so they are able. It can bond to 4 different elements, and it can form very stable bonds. And so you can create these really wide, large branching, single rows. You can have branching things. You can have these, the not spheres, like the buckyballs, like a soccer ball type thing. And it's all very strong. So it's really unique in the elements in respect to that.
let's talk a little bit about its kind of in culture. If you look at carbon in diamond form,
Diamonds.
there's been so many wars just started on diamonds, or if I know you've heard of blood diamonds. And there's just a lot of
they're so shiny.
They are, but it's been this alchemists for hundreds and hundreds of years have tried to recreate the diamond, its purity, its inability to be destroyed or scratched. But it wasn't until the 1950s that they were able to actually recreate diamonds in a lab synthetically. But it was with limited success.
Yeah, well, because you can take carbon you found in nature, and then if you put it under enough pressure, you can create a diamond. Right. So that was the key, is trying to be able to do that. But how much pressure do you need? And there's it's a little bit more complicated than just pressure, but because I watched a DuckTales episode one time, and they had elephants running over the coal and they turned into diamonds. Yeah, I was like, that doesn't happen. That's not
mountains.
We'd be rolling in diamonds.
And thousands of millions of, I don't know how many years.
Exactly.
But they were able to create it, and the idea of, I remember I taught this to my second graders this year. The idea that what if we could create like a solid glass, if we could make basically glass out of diamonds, or make other things out of diamonds so that they're unbreakable. Well, we can't recreate diamonds that big.
No.
And only in really one shape.
Yeah.
You can't make them like a pane of glass.
Yeah, like a sheet.
Yes.
Like a flat sheet. Yeah.
And so while it would be great to have like unbreakable glass or unbreakable lots of other things, it's just not something that scientists have really been able to do. Although they have made some diamonds that look and are really hard to discern from
natural diamonds.
Diamonds, which makes the jewelry industry go crazy because they're like,
no, because you don't want a synthetic diamond, even though it's like the exact same thing. We don't want a synthetic one.
You, he'll buy you a natural, real diamond.
That's right. What is that commercial? He went to Jared's.
Or every kiss begins with carbon.
Oh, I see what you did there.
It starts with a C. Let's talk a little bit about, do you have anything about early uses of...
Oh, yeah. So...
Carbon?
This carbon, this whole thing we're talking about. Here, I'm going through my research. These are my research notes.
The rustling of paper?
That's kind of what I do.
She has pages. I have one note in my iPhone.
And look how much she's pulling out. I'm like, I gotta go back to my notes. All right.
I wrote this earlier this evening because I left my notes in my classroom.
Oops. I'm just lucky I could find my notes in my office.
That's true.
Yeah. So it's been used a lot. So even as far back as the Egyptians and the Sumerians in 3750 BC, they used charcoal to reduce metal ore to make bronze and for fuels and things like that. The first recorded use of medicine was in 1500 BC. And they realized that it absorbs odor from putrefying wounds and the intestinal tract.
And they still actually do that, don't they?
Yeah, activated charcoal.
Filters.
Yeah, activated charcoal. That's what that is. It's carbon.
Yeah.
It's very absorptive.
It's a really good.
It's really absorptive.
Odor filter. So if you have some bad smells in your house, just throw some charcoal around.
Just throw that on that.
Just kidding. That would be a mess.
And we get black everywhere.
It would.
Yeah. They had 400 BC. They would treat a wide range of illnesses, including epilepsy, chlorosis, and anthrax.
Wow.
Yeah. Probably not really to the best end, but they did use it. Let's see. Using to filter water to make it potable in 450 BC.
Yeah, a lot of filters nowadays are charcoal filters.
And this was a big thing for ships, because how long were you on the ships?
Forever.
For like months, right? And to have real good drinking water for that amount of time, you allowed you to stay out longer by having that potable water
Smart
that you could create.
I can't even find my shoes in the morning. I also have an interesting little tidbit about it being used. The tattoos of the Otzi the Iceman. He is a 5,300-year-old corpse found frozen in the Alps. Ooh. His tattoos were inked from carbon.
Yeah, that is. It takes total sense.
It's from a 2009 study in the Journal of Archaeological Science. There's my little research plug there. Footnote. So that's all I have of early uses because I had more modern uses.
Yeah, well, what do you call modern? Is it 1800s modern? Where does modern end? I don't know.
Just keep going through history.
Let's see.
Just go. She's got so many
a bunch.
notes.
Well, you know what? What's really interesting?
Bring us through history.
In 297 AD, the Roman Empire, God help them, decided that science was bad. Let's burn all the books. Yes. So progress went down kind of for a few centuries or more.
The Roman Empire. I mean, from a theater major's point of view,
amazing.
Well, actually, no. Oh. During that time, they didn't allow any tragedies because they didn't want
don't people want sad?
And well, they didn't want any anyone thinking about how things can be different. All they wanted was slapstick comedy.
Yeah.
So if you know, what's that musical? A Funny Thing Happened on the Way to the Forum. That's a mockery of the Roman theater at that time because they were not allowed to talk about politics and they had to be really sneaky about it. Crazy. And so it created this form of, I'm going on a tangent about theater, but Roman Empire, man, boo.
Man, boo, they're bad.
Burning books.
It's crazy.
What are we, in a Ray Bradbury novel? What was his name?
Ray Bradbury.
Bradbury.
Yeah, Bradbury.
I got it the first time.
Yeah.
Fahrenheit 451.
Always go with your gut instinct. I tell my students that all the time, and they change their answer and they get it wrong. Well, so I'm gonna go up to in 1800s they started sugar refining in Europe, and they used ground and washed wood charcoal for colorizing syrups. Yeah. So I mean, pretty much let's see. So let's go over just some uses which have been used in the past and future. So we have, the inking, right? Fuel, pencils, crucibles, electrodes, lubricants, jewelry, drilling, cutting, grinding, polishing, printing, ink, black ink is black carbon, steel, which is an alloy of carbon and iron, which means putting two things together, mixing them, radioactive dating, chemical industry, there's a lot in there.
It's really interesting because graphite is actually considered a dry lubricant. Which
it sounds weird. It's a dry lubricant.
It's an oxymoron.
Yes.
And I actually
but it makes total sense.
Don't really know exactly what it's because isn't it because of the layers of graphite? There's so many
like a layer
layers
to it?
that it can move, but it's not a liquid.
That could possibly be. I do not know as much about graphite.
And I'll be honest, people, I didn't understand it, which is why I'm just telling you
industrial
words.
lubricant.
Yeah.
Yeah.
And, they use them in crucibles for steel in modern day right now. Which is it kind of blows my mind.
Yeah. Well, there's some simple stuff is still used very similarly to when it was used in the beginning. It's true. Yeah. So it's pretty cool.
we're both scanning our notes right now. Wait, what are we going to talk about next?
I was going to talk about
graphite. I want to just talk a little bit about
fuel. Hydrocarbons.
Okay, hold on. Okay. I'm going to talk about graphite.
Go ahead.
Graphite. How cool is graphite? First off, it's what's in our pencils, not lead.
No.
That actually came from, I believe, Roman times. The idea of using lead. It's graphite, people. You're not going to get lead poisoning from your graphite pencil.
No.
But also, it also can conduct electricity. Is used, as I said, as a dry lubricant and as crucible for steel factories and for brake linings.
Interesting. Lubricant, because you don't want to grind your brakes. Interesting.
You want to go into...
Well, so hydrocarbons.
Please tell me. I have no idea what
hydrocarbons you just went on with the brakes, and I'm going with the car theme here.
Go for it.
So the hydrocarbons. So hydrocarbon breaks up to hydro meaning hydrogen and carbon meaning carbon. So basically, I know. Sometimes science is
exploding.
Sometimes science actually makes sense. It doesn't have convoluted names for things.
No.
Occasionally. So hydrocarbons are basically just long chains of carbon and hydrogen. And so what do you do before a race, or what most people do before a long race?
You fuel up.
You fuel up with what? What do you say? It's some kind of loading.
Carb load. That took too long.
That's right.
I'm a runner.
Carbohydrate.
Right.
Is carbon and hydrate. Carbon hydrate. So carbohydrates, hydrocarbons.
Well, they're tricky because they switched it. Carbohydrate, and they're calling it hydrocarbons.
Yeah, well, I didn't tell you. I said occasionally they're straightforward. I don't know. So basically, it's the energy that's in most everything, is between the bonds of the elements. And so the long chains of carbon with a whole bunch of hydrogens on them have a ton of brains? No. They have a ton of bonds that you can break, and when you break those bonds, you release energy.
Okay.
So the carb loading is because if you eat like a sugar, a candy bar, you're going to be like, and then you're flat out, right? You don't get a lot of energy.
You burn all that energy quickly,
it's very easy.
And then it's gone.
Right. But with the carbs, you have to break down so many bonds to break down that one molecule, or the one compound, really, not molecule. But to break all those down, it takes a longer time. So you have a longer lasting energy source. Oh. So so it's basically hydrocarbons are fuel. The carbohydrates that we eat, also the gas that you put in your car, are hydrocarbons.
It's not just carbon, but it's hydrogen and carbon and
together
bond.
Yes. It's a whole bunch. It's a big line of carbons.
Big old long chain.
A big old long chain, and they can be branch chains, and they can be single chains, and they can branch off of branches, and all this crazy thing.
To chemistry.
I'm just saying. But the difference between those two is simply the arrangement of those like we said before, the carbon and the hydrogen.
We've been using carbon for fuel. I mean, forever. I mean,
well, you burn a tree. And you're burning carbon. You
literally right. No, you're literally like, when you eat food, that is energy from carbon. If you have coal, which there's a whole coal industry still, I don't know why. Okay,
well, it's still a good energy source.
It is. Yeah, it's found in the earth, and it burns, and it creates energy.
And so we take that. Yeah. So again, back to that thing before. We take that carbon in, and we break it up, and then we put it in different things. So your DNA, right, the genetic material that you have, has carbon sugars in it. A sugar made of 5 carbons. And so your DNA is based on carbon.
It's made out of carbon?
Partly.
Wow.
Yeah. So the backbone of your DNA is a 5 carbon sugar.
A figurative backbone, not a literal.
Well, it looks like a ladder.
It does.
Yeah. But anyway,
carbon is
you can't live without carbon.
Carbon is everywhere, man. We could be talking about carbon forever. Like, haven't even gotten into. Okay. Okay. So
should we move on? I mean, we've gotten some early uses. We've gotten some other things. So we can probably more on to the more recent uses.
I think so. Yeah. And it seems like, even though it was my subject, I think Cindy has probably more insight and better research done. I was really interested by the molecule that is now more commonly known as the buckyball.
My favorite. Although, and now every time I hear Bucky, I just think of the Avengers.
It's been
Bucky.
Yeah. It's been a long time.
Yeah, it's Captain America's friend that turns bad.
Oh, right.
The Winter Soldier.
Sorry.
Okay. We just saw a Black
I actually
Panther.
haven't seen the Winter Soldier.
Oh,
I haven't seen a lot of the new ones because I have a child. And I don't get to the theater. I don't actually see any movies. I get to watch a TV show on my treadmill at night while I'm running.
We took about a 3-year hiatus from being able to go to see movies. Yeah. Only recently we've been able to get back into it.
So I'm still in the 3-year hiatus.
Yeah, totally.
Okay. Makes sense.
Yeah.
Buckyballs.
Buckyballs.
Awesome. So the researchers who discovered it won a Nobel Prize in chemistry in 1996.
And there have been many discoveries that have gotten the Nobel Prize involving carbon. That is just one of them.
But buckyballs have been found to inhibit the spread of HIV. Did you know that?
What?
Yeah.
Inhibit
the spread
of HIV? Well, how?
I don't know.
What inhibit the spread within a person or between people?
Damn it, I don't know. But I'll tell you.
It's interesting. That is interesting.
I got it from livescience.com or LiveScience. I don't know. I don't know if it's LiveScience or LiveScience.
Oh, I went to that one too.
Yeah.
Yeah, I think LiveScience.
Yeah. I also
LiveScience. I think LiveScience.
I don't know. It's one of those tricky English
Stupid
words.
English words.
Actually, it's called a
what is it? You can have two. It's something she's thinking really hard.
It's a homograph.
Oh, there we go.
It's a word that is...
Oh, homo means same.
Yes.
Same
but graph means to write or to draw. And so it's written the same, but it's pronounced differently. And it has... Well, that one kind of has the same meaning. But,
yeah, but somebody's going to have very different...
But some of them, like present and present. Sorry,
right.
I teach second grade. I teach it. So... So... Tell me more. Do you have more about buckyballs?
Buckyballs.
It's just really fun to say buckyballs.
Now we're getting back to little kids.
Yeah,
Bucky balls.
now I'm acting like a second grade boy.
That was funny. I did have something about buckyballs. Well, I mean, the buckyballs, along with like just the new carbon fibers and stuff. Like, if you've gotten like a new tennis racket that's made out of carbon fiber, it's much stronger and much more lightweight. So it's been more cutting edge of using that in.
Well, just carbon
everything.
nanotubes in general.
Nanotubes.
They're extremely strong.
So nano means really, really small.
Yes, and they're extremely lightweight, and so they're actually used most commonly in. Hold on, I'm trying to look at my notes. Structural reinforcement because of its high strength and low weight.
Exactly. So we had the amorphous carbon, the graphite, and the diamond. Those are more natural ones.
And amorphous, again, for the people that weren't listening the first time,
is without
change.
Yeah,
so basically
it's just kind of a blah.
Charcoal.
Yeah. Mm-hmm. But the other ones called fullerenes and graphene are the nanoforms.
Okay.
Which it kind of includes the buckyball type thing.
Well, really, nano is basically scientists changing it more
so it's thin. It's thin sheets of graphene. The fullerenes is it graphene or graphite? No, graphene.
No, there's graphene as well.
So it's the no, but I have it here. I don't know. Really bad note taker sometimes. But it's basically like one layer. Versus like most of the fullerenes and graphene thing are stacked layers. So they basically ripped off every other layer and left one tiny remember an atom is so ridiculously small.
It is.
That to have just one layer of atoms is crazy. And that's what that is.
That's a lot of science.
Yeah, and so it revolutionized the electronic industry and nanotechnology in general. Is just like.
No, they're really doing amazing things. I think they're even starting to try and create different types of armor with carbo nanotubing and but again, this is stuff that's not affecting too much of our culture, I feel like, as of yet. But I feel like it will.
Yeah.
But tell us more. Talk about C14, the radioactive.
Well, I have a little bit about.
Okay. Sorry,
I'll go into that one in a second.
Okay.
But the graphene, it's the graphene, those single sheet of atoms, is the strongest material known, but still ultralight. So now this is the one that's been now stronger than diamonds. Diamond was the most strongest. Graphene is that thin layer. It's flexible, conducts electricity, as you kind of said, and better than copper even. And if you've ever torn down a house, you have copper wire everywhere.
Yeah. So it's actually really copper's kind of like people will go into old houses and rip out the copper wire.
Oh yeah, we did when we bought a house that we tore down.
Yes.
And so Steve went in and
make sure you say that we went into a house we owned. Yes, took all the copper wiring.
We destroyed the house that we bought and then took the copper wire out.
Broke into a house and stole all the copper wiring from the inside. What do you mean? Just kidding.
No.
Internet.
Just kidding. So yeah, it was the graphene is you take off the layers. So if we can have something that conducts electricity even better than copper,
and something that we don't have to find in nature, but that can be made.
Right, we can make you just take graphite and be like.
That would save us a lot of money and be easily reproduced and would help our society.
Exactly. It's 1/6 as heavy and better than copper. It's 100 times stronger than steel.
That's crazy.
The nanotubes. And the nanotube process can take salt out of seawater more effectively. Which could be a huge issue
when we run out of our fresh water.
Right, which, could happen. That's the way we're going.
I read a lot of sci-fi and a lot of post-apocalyptic novels, and so I'm like, when we do run out of fresh water...
It's going to be a problem.
But not if we have this.
No.
Science, go!
Yeah. I'll attest to having fresh water on a boat. We were out in... I do dolphin research on the side. My other days. In the Bahamas. I know, so sad. But we were on a boat, and we had our freshwater, but we had a reverse osmosis system. So we take salt water in and make fresh water. So it's really handy to be able to have, and if we could do it more easily, there you go.
That would be fantastic.
Yeah. So back to C14.
I think we have a little bit of time to talk about carbon dating and radioactive C14 before we run out of time.
So this is really another ding, because C14 is an isotope.
Bum, bum, bum.
Iso means the same, but basically means almost all elements have different kind of versions of themselves based on their atomic structure of how many neutrons they have. But C14 is a radioactive version of carbon, basically.
Okay.
So that's why it's, instead of C12, that's normal
So it
version.
can turn me into Spider-Woman.
No.
Dang. What's the point of C14?
No, radioactive stuff will just kill you.
Oh.
Yeah. Sci-fi has ruined us for that. You're not going to turn into some awesome
But tell
being.
us, why is C14, the radioactive form of carbon, important?
Because we can date things. So we can see how old something is.
I'm married. I don't need to date anymore.
Not that kind of dating.
Oh.
Yeah. Like the actual, like, Julian calendar date.
Julian, huh?
Julian is Julian. Maybe we need to date Julian. So if we want to find out, if we find a fossil, we want to find out how old that fossil is. We can use carbon dating, because carbon, as we said, is in everything.
Right.
So the carbon 14, so something that's radioactive breaks down at a specific rate.
Okay.
So it is what we call a half-life. So there's a certain amount of time where half of it will be gone.
Okay.
And so based on each one, we know all these different isotopes, we know what their radioactive decay time is. You can then use that and say, well, if this is how much is left, this is how much we should have started with, this is how much time has passed.
And how old it is.
Correct.
Wow.
Yeah. So
You want to hear a funny joke?
yeah.
About. Okay. So why are geologists always single?
I don't know.
They date rocks.
So true, literally, and also in a funny way. I like it.
My
That's a
geology
good
teacher
one.
in college taught me that.
Well, I'll have to tell my students. Yeah. I tell them a lot of knee slapper jokes. Sometimes I'm the only one laughing.
I'm
but
always
it's good.
the only one laughing.
I love it.
So that's really cool. I do want to talk real quick about that Wow in the World episode.
Oh, yeah.
If you have kids and you want your kids to be really excited about science as well, there's a great podcast called Wow in the World.
Wow in the world.
Doo-doo-doo.
Yeah.
And they
Super
had
fun.
a whole episode about raining diamonds. And it's the idea that, I don't know if it was Neptune or Uranus. I want to say it's Uranus because I had my students read it or listen to it in class. And I just was like, please say Uranus. Don't say it the other way. Because
that one says Saturn and Jupiter.
oh, well, really?
Crazy.
I feel like they wouldn't be.
Oh, and solid diamonds on Uranus and Neptune.
Yeah,
So we were both right.
The idea is that it's so cold on the outside of the planet, and it's so hot on the inside of the planet that it creates an immense amount of pressure, and so
pressure causes diamonds.
yes, and so there's a theory that there's so much pressure in the atmosphere of these planets that it could be possible that it is literally raining diamonds.
And not just small tiny diamonds.
No, like boulder,
giant diamond
like
diamonds.
giant
Huge.
boulder diamonds. And I just thought that was so cool. And of course, I'm trying to explain this to my second graders about like a planet rotation and like pressure and explaining how diamonds are formed. So I'm like, pause, okay, kids. About every 10 seconds. So I thought that's an amazing idea. Now, that's not where it's found in our planet, but it's possible that there could be these enormous... I wouldn't want to be there, though, because then you're dodging enormous boulder diamonds.
Which are still like one of the hardest materials known.
You would die.
So, but I mean, what a way to go.
Right.
Being crushed by a boulder-sized diamond.
On Neptune.
Yeah.
Or Uranus.
Well, carbon is it's very abundant. So it's the fourth most abundant in the universe and sixth most abundant element. Like, depending on who you ask, kind of it's pretty abundant.
However, in its natural form, it's more it's like in medium supply, moderate supply, which you can learn a lot about this element and other elements on the periodic table by going to the Royal Society of Chemistry, which is a fantastic resource that we both use.
We did.
We just realized we both used.
Like, that was the first one.
I know, me too. So they also have podcasts, but they go a little more mathematical and in depth. Their podcast on carbon is all about diamonds, and they throw out a lot of numbers. And I read the transcript and went, "Wow, not for me." But if you have listened to this podcast and you've gone, "Wow, I really want to learn more about carbon," you can use that. We'll also have our other resources on our page.
I mean, 10 million compounds with carbon in it have been discovered.
That's a lot of compounds.
Yeah, it's the keystone for 95% of known compounds. I mean, it's just there's so much to learn about it.
Yes.
Yeah.
So I think that wraps up our episode on carbon.
Yes, I think we kept it close to our 30 minutes. Oh,
yes.
34. Yeah, we're doing pretty good.
So thank you so much for listening.
Hope you had fun.
I hope you did.
I had a great time.
Well, we hope that you'll be listening to us again soon. My name is Grace.
My name is Cindy.
And this has been Elemental Fun.
Till next time.
Bye. Is it found in nature?
In nature. Well, do you know that the carbon that's in your body comes from the much of it comes from the carbon dioxide that you breathe in?
I did not.
Yes. So this is where the chemistry part comes in here. So
I got my bell ready.
So ready to go. You breathe in carbon dioxide, and through cellular respiration, which is the opposite of photosynthesis.
Oh,
basically.
that makes sense.
Mm-hmm.
Yeah.
So we take that carbon dioxide, or we take. Oh my gosh, we don't do that. We do
We
not take
plants
carbon
do
dioxide.
that.
Right. That's the photosynthesis part.
Right.
It's super late. So through cellular respiration. Wow, we need to start this all over again.
Okay.